Good afternoon. My name is Omilabu, and today I'll be presenting the culmination of 8 weeks of research at the Laidlaw Lab, respiratory inflammation, immunology, and allergy. So my research focuses on aspirin-exacerbated respiratory disease and how the deficiency of an enzyme called aldehyde dehydrogenase 2 in the local nasal tissue leads to dysregulated alcohol metabolism and respiratory reactions in patients with AERD. Alright, so in this presentation, I'll be going over exactly what AERD is, some of the more prominent symptoms, the typical medical interventions. I'll also be going over alcohol as it pertains to respiratory reactions in AERD. And I'll introduce a term called alcohol flush and how it's linked to aldehyde dehydrogenase 2 deficiency. And lastly, I'll be going over my experiment and the results. So, what is AERD? AERD, or aspirin-exacerbated respiratory disease, it is a disease that makes the nasal congested upon the ingestion of aspirin. It is mostly characterized by a classic triad of chronic rhinosinusitis with nasal polyps, asthma, hypersensitivity reaction to COX-1 inhibitors. COX-1, also known as cyclooxygenase 1, secretes prostaglandin, which helps mediate tissue pain and causes inflammation. However, patients with AERD cannot take these COX-1 inhibitors because they'll have a respiratory reaction. So they'll basically have a mini asthma attack. So just think about the typical drugs that you guys use every 2 to 3 weeks. It could be aspirin, ibuprofen, Aleve, Alka-Seltzer. Patients with AERD cannot take these drugs because they'll have a respiratory reaction. And also think about a time when you felt awful, like your nose is blocked, you couldn't breathe. Patients with AERD face this on a daily basis. So how common is this disease? We know that 7% of adults with asthma have this disease, and we know that 1/4 of adults with severe asthma and nasal polyps have this disease. And lastly, we know that it affects all sexes and races. We also know that this disease is more common than you would expect because there are roughly 1.5 million patients in the United States, which makes this disease incredibly underdiagnosed. So one of the main characteristics of AERD is the formation of nasal polyps. Nasal polyps are soft growths that develop on the lining of the nasal passages or sinuses. The most common treatment for patients with AERD is to surgically remove the nasal polyps. Although this can be removed by elective surgery, the main problem is the rapid regrowth of the nasal polyps. The average recurrence of the nasal polyps is about 6 months. As you can see from the image on the left, this is a picture of a patient with AERD and rhinoscopy. The left side and the right side is just healthy, normal tissue, and inside you can see the nasal polyp. You would describe it, or some would describe it as like a booger, or if you were to like peel off a green grape, like the skin of the green grape, and put it into the nostril, you could also say that. We know that half of our patients report these nasal polyps regrowing in less than 6 months, or exactly at 6 months. And the image on the right is post-op. So you can see the extraction of the nasal polyps, diameter of 2 inches. And this is only one side of the nose. So you can imagine that there's 4 to 5 times that amount on the other side of the nose. We know that 60% of our patients have had 2 or more surgeries. 10% of our patients have had 5 or more surgeries. And as you can suspect, this can be quite exhausting and debilitating because you would have to like continuously keep up to date with like surgery after surgery over and over again. And we also know that almost all of our patients completely lose their sense of smell. So I would like to introduce you guys to some of the more prominent upper and lower respiratory reactions. Upper respiratory reactions consist of congestion, sneezing, facial redness, and swelling. And the lower respiratory reactions consist of wheezing, coughing, basically an asthma attack. Less common would be vomiting, nausea, abdominal pain, and crash. So Dr. Laidlaw and her team conducted a study in 2014 where they basically gathered 50 participants from 4 clinical groups, patients with AERD represented red bar, patients with aspirin-tolerant asthma, represented by the blue bar, chronic rhinosinusitis, green bar on the nasal polyps, and white bar on healthy patients. And they basically enforced a questionnaire asking them whether they experience respiratory reactions after drinking alcohol. And these are the results. According to graph A, 75% of patients with AERD reported having upper respiratory reactions. Graph B, 51% of patients with AERD reported having lower respiratory reactions. And then a whopping 83% of patients with AERD reported having any respiratory reactions. And keep in mind that this isn't related whatsoever to intoxication. Patients reported these respiratory reactions being triggered upon within wine, or just a few sips of wine, beer, and liquor. And this is important because it not only shows that patients with AERD have respiratory reactions when they ingest NSAIDs and aspirin, it also shows us that they also have respiratory reactions when drinking alcohol. And the underlying cause of alcohol-induced respiratory reactions in AERD is unknown. Okay, so this is completely unrelated to AERD. I promise it would all make sense in the future. So, what is alcohol flush? A large portion of patients of East Asian descent experience intense facial flushing, occasionally accompanied by dizziness and nausea, upon consuming alcohol. This syndrome is often colloquially referred to as Asian flush or alcohol flush. It occurs due to a deficiency in the expression of the aldehyde dehydrogenase 2 gene, which is absent in the genotype of East Asians. This gene normally helps with detoxifying acetaldehyde, a toxic substance produced when our bodies metabolize alcohol. As you can see, the alcohol flush affects roughly 35 to 40% of East Asians, and that's 8% of the world's population. The syndrome is so severe, or symptoms are so severe, that many East Asians just entirely avoid alcohol. You see from the illustration, this is pre-alcohol and post-alcohol ingestion. So, aldehyde dehydrogenase 2 is a mitochondrial enzyme found in the liver, which makes sense that patients would exhibit systematic symptoms because we all know that the liver plays a critical role in metabolizing alcohol. So its main job is to break down and get rid of a toxic substance called acetaldehyde, which is produced when we drink alcohol. This process is important for detoxification. When we drink alcohol, our bodies use specific genes called alcohol dehydrogenase 1 and alcohol dehydrogenase 3 to convert ethanol into acetaldehyde. Then another set of enzymes, aldehyde dehydrogenase 1 and aldehyde dehydrogenase 2, help break down the acetaldehyde even further. So they detoxify acetaldehyde and turn it into a less harmful substance called acetic acid, or acetate. Then the acetic acid is partially associated into carbon dioxide and water. So basically, aldehyde dehydrogenase 2 and other enzymes work together to break down alcohol and the toxic byproduct it produces. This helps our body process alcohol efficiently and avoid harmful effects. So because of the similarities in the reactions that occur systematically in East Asian patients with small amounts of alcohol and locally with AERD patients with small amounts of alcohol, we hypothesize that patients with AERD who are hypersensitive to alcohol will have lower expressions of aldehyde dehydrogenase 2 in their respiratory tract. This could be found in the nose or lungs. And our main objective for this experiment was to determine whether a deficiency of the aldehyde dehydrogenase 2 in the nasal tissues of patients with AERD could account for the alcohol-induced respiratory reactions these patients face. So we extracted, for the methodology, we extracted nasal tissue samples from the operating room. Patients with AERD, aspirin hypersensitivity, plus asthma, plus the nasal polyps with kind of chronic rhinosinusitis. And then we also extracted nasal tissue samples from patients with aspirin-tolerant chronic rhinosinusitis with nasal polyps and without nasal polyps. And then we ran an RNA sequencing of cells from the nasal tissue. In hopes to investigate aldehyde dehydrogenase 2 expression. And then we measured the ELISA. We measured the aldehyde dehydrogenase 2 protein by using the ELISA, and then we normalized the aldehyde dehydrogenase 2 protein to the total amount of protein. So the figure on the left shows single-cell RNA sequencing, where the aldehyde dehydrogenase 2 gene is expressed in the human nasal tissue. The purple dots represent cells that have aldehyde dehydrogenase 2 expression. As you see from the graph, the gene is mostly expressed in the epithelium, endothelium, fibroblasts, and macrophages. Keeping this in mind, the image on the right shows the cell transcription of nasal epithelial cells. Purple represents low expressions of aldehyde dehydrogenase 2, and green represents the opposite. So a member of our lab took these cells and he grew them out and separated them into chronic rhinosinusitis without nasal polyps, chronic rhinosinusitis with nasal polyps, and AERD, chronic rhinosinusitis with nasal polyps, and saw that the aldehyde dehydrogenase 2 expression was less in the nasal epithelial cells of patients with AERD. So we started by identifying 10 non-Asian patients with sinus disease with no nasal polyps, no ERD, and no report of any alcohol-induced reactions whatsoever. And then we measured their aldehyde dehydrogenase 2 protein levels in their sinus or nasal tissue and found quite a bit. Then we chose 10 nasal polyp samples from patients with ARD who had reported reactions to alcohol and tested their levels of aldehyde dehydrogenase 2 protein side by side. Upon protein normalization, unbelievably, we found that there were substantially lower levels of aldehyde dehydrogenase 2 in patients with AERD who have alcohol-induced symptoms compared to patients with chronic rhinosinusitis without nasal polyps. These results were statistically significant with a p-value of 0.02. We have been considering the possibility that the acquired aldehyde dehydrogenase 2 deficiency and the findings that we've gathered could be related to the alcohol-related respiratory reactions observed in these patients. It appears that the patients may struggle to degrade acetaldehyde effectively, leading to the development of respiratory reactions. To validate these findings and understand the underlying mechanisms better, further research is needed. So our next steps are to investigate diagnostic implications of the aldehyde dehydrogenase 2 deficiency. Because if there's a clear association, the aldehyde dehydrogenase 2 levels could serve as a biomarker for identifying patients that are at risk of experiencing alcohol-induced respiratory reactions. This will in turn enable clinicians to provide targeted advice and better manage such respiratory reactions. Another step we can take is to promote awareness among patients with AERD regarding the potential risk associated with alcohol consumption and its impact on their respiratory symptoms. So I'd like to give a special acknowledgement and my appreciation to my PI, Dr. Laidlaw. Thank you so much. I thank you so much for your unwavering support and your mentorship. Thank you for being patient with me, and also I would like to thank Laura Cho, our lab technician. Thank you. And Akeem for helping with the experiments. And I would also like to extend my appreciation and gratitude to the entire ARD family and the team. Thank you so much, Dr. Chen, Katie, Rose, Allison, Laura Bailey for just being there. And lastly, Fred, Tina, and Dr. Henderson, thank you so much for giving me the ability to do research here at Brigham and for giving me such a memorable and intellectually enriching experience. Thank you.